We've all been there. A scraped knee, a cut finger, maybe even something worse like a broken bone. One minute, everything's fine. The next, there's damage. And then, slowly, almost like magic, we're whole again? But have you ever really stopped to think about what's actually going on under the surface? So, our story today kicks off right here with a middle school student who had a pretty bad accident and broke his foot. Suddenly, he couldn't walk, he couldn't run, all the things he loved to do. It's a tough story, and one a lot of us can relate to. And yet, we kind of know how the story usually ends, right? With a little time, the body does something absolutely incredible. It rebuilds itself. It fixes what's broken. It performs this quiet little miracle that, honestly, we all take for granted. So that is our mission for this explainer. We are going to peel back the layers and get to the bottom of that very question. What is this hidden engine inside our bodies that fixes us when we're broken? For this student, the path to getting better was a full 4-month journey. It started with the injury itself on day 0. Then came the stitches, a cast, even some pins. And then finally, 4 months down the road, a totally healed foot. Now this timeline gives us the big picture, but the real story, the amazing part, is happening at a level we can't even see. Okay, so to understand the repair process, first we have to know what parts were actually damaged. Think about it like being a mechanic, right? You got to know the components of the engine before you can even think about fixing it. In this case, the injury affected 3 main systems in the foot. First, you've got the skin, our stretchy, protective outer layer. Then there's the muscle. That's the springy tissue that pulls and contracts to make us move. And finally, deep inside, the bone, the solid, hard framework that gives us our shape and support. Each one has a totally different job, but they all have to work together. So that's what we can see with our own eyes. But what if we could put all of this under a microscope? What if we could zoom in, way, way in? What are the actual fundamental building blocks of our skin, our muscle, and our bone? And this brings us to the next really cool part of our investigation, diving into the microscopic world. We're about to uncover the tiny engine that powers not just our bodies, but pretty much all living things. And wow, when you look this closely, you see something amazing. Skin, bone, and muscle. They aren't just solid chunks of stuff. They're each made of these incredible repeating patterns. As you can see here, skin on the left, bone in the middle, and muscle on the right, they all look really different, but they all share this one fundamental thing. It turns out each of these tissues, in fact, every single part of a living thing, is built from countless, tiny, individual living units. And these units have a name, of course, cells. The cell is the absolute smallest unit of matter that can be considered alive. It's like the brick that builds the entire house of life. You, right now, are basically a community of trillions upon trillions of them. And here's the brilliant part, where form follows function. The long, stringy shape of muscle cells, perfect for contracting and pulling. The way skin cells are packed together so tightly creates an amazing protective barrier. That organized, rigid matrix of bone cells gives us strength. Basically, a cell's shape is its job description. So, how does this all circle back to our student and his broken foot? Well, if the body is made of cells, then it stands to reason that healing itself has to be a cellular process. So, on the microscopic level, an injury, whether it's a small cut in your skin or a big break in a bone, is basically a gap. It's just an empty space where cells are supposed to be. The problem of healing, then, is really just the problem of filling in that gap. So how in the world does the body do it? I mean, it's not like new cells get trucked in from somewhere else. They have to be made right there, on the spot, at the site of the injury. But how? The answer is this just remarkable process called cell division. An existing, healthy cell right on the edge of the wound gets ready by doubling everything inside itself. Then all those copies move to opposite sides, and the cell just pinches in the middle until it splits into 2 brand new identical cells. Just like that, 1 becomes 2, and you can see the incredible result right here. That process just repeats over and over and over. Cells at the edge of the gap divide, making new cells, which then divide, and on, filling the space. It's like a construction crew that literally builds new workers and new materials right there on site. Slowly but surely, the gap gets closed. And this is the fundamental rule of repair, the whole secret really. Cells make more of their own kind. Skin cells divide to make new skin. Bone cells divide to make new bone. This isn't magic. It's the orderly, precise, incredible work of our cells. That's how we heal.
But get this incredible engine of cell division doesn't just switch on to fix us when we're broken, it's the very same engine that built us in the first place.
Take a look at these two images. On the left, you've got a scraped knee that's healing, cells are dividing to fill a gap. Now look at the right. You see these x-rays of a child's hand getting bigger over the years? Well, that growth happens at spots called growth plates, which are really just gaps in the bone that are being steadily filled in by, you guessed it, new cells making more new cells. So you see, healing isn't some special, separate ability our body pulls out of a hat when we get hurt. It's the exact same process of making new cells from old ones that allowed every single one of us to grow from a single cell into the person we are today. Repair and growth are two sides of the very same biological coin. I mean, it's a pretty profound thought when you stop and think about it. This constant, quiet work of ourselves, dividing, rebuilding, growing, it's all happening inside you right now. It really makes you wonder, if our cells hold the blueprint for building and rebuilding an entire person, what other amazing secrets are they just waiting to reveal?